Today we are going to start matrices of class 12th. It is a part of algebra and you will get either 4 or 6 marks question from this chapter. We all have seen the matrices. We go to the airport, bus stop or railway station. So we see all the timetable fixtures and this all fixtures are in the format of the matrices. So actually matrices is the rectangular arrangement of numbers and the main application of this is solving the equation system of equation having n number of variables. In 10th standard we have solved till 2 variables or 3 variables, but by using of this matrices we can solve the system of equation having n number of variables. So the actual definition of matrices is matrix is an arrangement of numbers, symbols, or expressions in rows and columns. It is represented by a big bracket or small bracket. So I give you example of that. We can write the matrix like this also, by this also, and inside of that there will be elements. So both are the matrix. And in the definition, it is given it is the rectangular arrangement by the row and column. So what is the row and what is the column? So row of a matrix is how many horizontal lines you can draw in a one matrix. So one horizontal line, two horizontal lines. So there are two rows in this matrix. Now column is the total number of vertical lines. So one vertical line, two vertical line, and three vertical lines. So there are three columns in the matrix. Similarly, in the second matrix, we can draw two horizontal lines and two vertical lines. So there are two rows and two columns. Now we come to the order of the matrix. Order of the matrix is the number of row multiplied by the number of column. So according to this, the order of the first matrix will be, see here, three vertical lines and two horizontal lines. So order of the matrix will be the first we write the row, then we write the column. So the number of row here it is 2 and the number of column is 3. So the order of the matrix is this is 2 by 3. We come to this matrix if it's having a 2 row and 2 column. So it is 2 by 2. So I think till here it is clear to everyone. What is the matrix? Matrix is the rectangular arrangement of numbers. What is the order of the matrix? The number of row multiplied by the number of column. Row is the horizontal lines and column is the vertical lines. Now after this, how we represent the elements in the matrix? We write like this: A11. A11 is first we represent the row then column. A11 is the first row and first column. So in this matrix, what is the element in the first row and first column? It is, you can check, it is 1, this part. This is the first row and first column. Same if you go to the A12, so it is first row and second column. So we can see this is the first row and second column. So it is 2. Similarly, we can write all the elements. So 6 will be second row and third column. I think it is clear to everyone how to represent the elements of the matrices. So now we come to the types of matrices. Types of matrices. See, the first type of the matrix is the row matrix having only row elements. What is the meaning of this? Meaning of this is key we will get a single row in a matrix, then that matrix will be the row matrix. I give the example of this. See, if we have matrix like this 1, 2, 3, 4. So in this matrix we have only one horizontal line. So this matrix has only one row but four columns. So definition of the row matrix is having only one row. So this one is row matrix. This one, this is also a row matrix because we have only one row. If I write this one, so this is not a row matrix because it has two rows. So row matrix is the matrix which has only single row. Now our second type is column matrix. So it is just the reverse of the row matrix. In the row matrix, we have done the matrix have only one row. And now here, so all the matrix have the single column is called the column matrix. So we have three row and one column. Here we can write, see, we have three row and one column. So column matrix which has single column. So this matrix has single column. So this matrix is the column matrix. Thank you.